In this video, we're going to demonstrate that our machines do not produce any ozone. So when you purchase a machine, it's really important to know that the purity of the gas is actually very high. And on our website, we actually have a document where we present some official lab reports that verify that the purity of the gas produced by our machines is in the region of 99.5% or more. And so in this particular video, we're specifically going to demonstrate with two different techniques that there is no ozone present. And the two methods we're going to use are some test strips, which in this case is potassium iodide starched paper, and a sensor or reader here, which is an electrochemical sensor. And the reason I point out the kind of sensor that is because there are cheaper sensors known as MOS sensors, which actually stands for metal oxide semiconductor. And these devices, these MOS devices, can actually react to hydrogen. And if you're using one of those devices, you could get the impression that the machine that you're testing is producing ozone when it actually isn't. It's just a cross reaction and therefore not an accurate measure. So you want something, if you're going to measure yourself, a specific electrochemical sensor for ozone, or something like the test strips that we have here. And if you use one or both of those, you'll be able to confirm for yourself that whatever device that you're using has or has not got an ozone production to it. So the machine that we're going to be using for the testing is the Immortal device. So this is our most powerful machine with an output of 3,000 milliliters per minute of gas. So we've got it set up so we've got the Y adapter, and both gases from oxygen and hydrogen are coming through and outputted through this part here. So the first test that we'll do is with the potassium iodide starch paper, and that comes in a little bundle of test strips. And so we've taken one of those test strips here and we've just dampened it a little bit because that makes it more reactive. And if we switch the machine on, we just wait for the bubbling to occur in both bottles. And we'll just wait for a moment to allow the full impact of the hydrogen and oxygen to be coming through. So what we can do now is take that output nozzle and we can put this so it's kind of going straight onto the paper there, and there's absolutely no reaction occurring. And what we're going to do a bit later is we're going to show you what a reaction would look like by exposing this test strip to an ozone source. So you can see exactly what would happen when ozone is present. But there's the full force of 3,000 milliliters per minute going straight onto that paper, and there's no reaction occurring. So that's kind of one way of validating. And then what we can do is we can have a look at the meter here. So on this meter, the kind of background reading is 0.01. And if we kind of expose the sensor, so we've got kind of the sensor at the back here, but you can see that the reading there is not changing at all. So it's staying at 0.01, 0.02. And that's exactly the same as if we have the reading just on its own without anything. It just fluctuates between 0.01 and 0.03. So that just seems to be the background level of ozone in this room. So it might be worth just putting those readings into some kind of context. So the readings on the meter in the room that we're in at the moment are fluctuating between 0.00 to 0.03. And generally speaking, background ozone levels, if you were outdoors, can be generally between 0.02 to 0.05. In more urban areas, you might get 0.05 to zero point 0.1. So that's a higher level of ozone. For indoors, for anyone that's not using some kind of ozone generator, you would look usually to have something which is 0 to 0.02 as ideal. And you might find that if you've got the window open, it might go between 0.02 to 0.05. So what we have here is an ozone generator, and I'm only going to have this switched on for less than hopefully 30 seconds because the ozone levels are going to increase very quickly. But it's to show you that with the ozone strip, detecting strip, we should show you what a reaction will look like. And also with the meter that we've got here. And you can see the meter is still fluctuating in exactly the same way between 0.3 and 0.00. So that's just been consistent all the time. So that seems to be the background level. So I'm going to switch that on. So at the moment, I'm just holding this so that you can see the reading. And if I bring it closer to the ozone reader here, to the ozone machine, we're starting to get readings now which are right up over 35. So that's a 50 and so on. So that's showing you a reading of ozone. And then with the strip, I can bring that in front of the ozone device. And what you see is a change of color. And you can probably see that that's starting to go a completely different color. So the ozone strip originally looked like that, and it changed color to this. So this shows you that this strip does genuinely detect the presence of ozone. It detected it from an ozone generator, but didn't detect it coming from a very powerful 3,000 milliliter per minute machine when the ozone was directed straight onto it consistently. This device picked up, and it's still picking up in the air now, a high level of ozone, but that went up very rapidly. And this is absolutely detecting ozone from an ozone generator, but absolutely nothing from our machine. So using two different techniques, we've been able to hopefully demonstrate that there's no ozone being emitted from our machines, and you can kind of have a bit of peace of mind and a bit of reassurance on the purity of the gas coming out of our machines.